All right, this is question chapter 5, number 1, and it's on DR plotting, dead reckoning plotting. So go to chapter 5 solutions book. And the description of the problem is here, and here's some general guidance for it. You want to answer this question using the plotting sheet in Appendix E and the deviation table from chapter 5. The compass rose in Appendix E shows a variation based on 1985 information, and we'll talk about that in a minute. You're going to correct this to the year of the question, and the question states, at 0700 on 23 September 2002, you're located at point E. You record the following data in your deck log over the next few hours. And notice that in the logbook, here's the date, September 23rd, 02, and these are the times, every half hour. And then under this column is course steered, and this is PSC, per ship's compass. The next column is distance log reading at that time, and then this last column is for navigator calculations, and we'll go through this in detail. Now, be aware of the fact that the course that's put in here is the average course that was steered during the previous half hour. So this 001 degrees refers to the average course steered from 0700 to 0730. It's not the course at 0730, but it's the average from 0700 to 0730. And likewise for the remainder of them. These numbers under the distance column are the log reading, or the odometer reading, at that time. To get the distance for that half hour period, we're going to do a subtraction, and I'll go through that with you in detail. Now let's come over here to the compass rose on this plotting sheet, and notice the compass rose has an outer ring, which is the true degrees, and the star at the top signifies pointing towards the North Pole. So therefore this line from here to here is parallel to a longitude line, north-south longitude line. Then there's an inner ring, which is the magnetic North Pole. And you notice a little arrow here, and that arrow is pointing towards a magnetic North Pole. And that's because true north and magnetic north are not the same. And it varies with time. So if you come in and look closely at the inside ring here, it says VAR, variation, 8 degrees 00 minutes west, paren 1985. That means in 1985 the variation for this point on this chart was 8 degrees westerly. And then it says annual increase 5 minutes. That means the variation is increasing by 5 minutes per year. So what we have to do is correct this for the year that we're doing the problem. And we're doing the problem in the year 2002. So right here in your books, we calculate variation as follows. And you notice I have 2002, the present year, minus 1985, the year of the compass rose, equals 17 years, times 5 minutes per year equals 85 minutes increase. Variation in 1985 was 8 degrees 0 minutes west. We're going to add to that 85 minutes and get 9 degrees 25 minutes westerly variation. Now, the steering compass on a small boat, or recreational boat, are generally divided into 5-degree increments. And it's therefore impossible to read it closer than about 1 degree. But you can read 1 degree. So when we have something like this, 9 degrees 25 minutes, we're going to round that to a whole degree. And we'll round down, since this is 9 degrees 25 minutes is less than half. We'll round down to the whole degree, and that's the variation that we'll use for this question. So let's look at how this is done. We'll take TVMDC, true, variation, magnetic, deviation, and compass. And this refers to the true direction, the variation that we just calculated, magnetic direction, deviation of the compass, and the compass reading. Now, what we have to do for this is write in the compass headings. And the compass headings, the first compass heading was 001. Course of 001 PSC, per ship's compass. So let's come and look at the deviation table over here, and you'll notice that for a ship's heading of 0 degrees, the deviation is 2 degrees west. For 30 degrees, it's 3 degrees west. Well, our 001 compass heading is very close to 0, so we're going to just use 2 degrees west as our deviation. So we're going to put 2 west in here. And in order to calculate the magnetic, I have to decide whether to add or subtract the 2 to the 1. Well, the rules are, if I'm moving in this table from left to right, if my number is westerly, so for westerly, either variation or deviation, if I'm moving from left to right in the table, I add the number. If I'm moving from right to left, I do the opposite. I subtract the number. If I have east variation or deviation, and I'm moving from left to right, I'm going to subtract. And if I'm moving from right to left, I'm going to add. So in this case, I have 001, and I'm moving from right to left, and the deviation is 2 westerly, so I'm going to, see, moving from right to left, I'm going to subtract. So I'm going to subtract 2 from 1. Well, this 1 is really 361. I'm going to add 360 degrees to it. So take 361 minus 2, and the magnetic therefore becomes 359. Okay, the variation now, as we already calculated, was 9 west. So here I put 9 west in here, and following this rule again, going from right to left, I'm going to subtract, so the true becomes 350. 359 minus the 9. So that's the method by which we work through this table and calculate the true. Now, I've done this in the solutions book for all of the courses. These are the courses from this part. In other words, we had 1, 001, 76, 319, and so forth. I've simply rewritten those here, did this deviation correction as I just described there, got the magnetic for all of those headings, included the variation of 9 degrees, and then calculated the true heading. Now we have these truths. What we'll now have to do is go back to our logbook and remember that this was your basic logbook page. This is what you're writing in your notebook while you're navigating. And you notice that we have a column that's called Navigator Calculations. This column, we're going to calculate 2 things. One, we're going to put in the true course heading, because that's what we're going to plot. So all we're going to do is transfer the information that we've already calculated here, and we're going to transfer it to here. And that's been done for you in this section right here. I've just reproduced it here. The next step, though, is to calculate the distances. And this is the odometer reading at 0730. You know, it's 432.6 from 435.6, gives a distance of 3.0 traveled during that half-hour period. And to do the same thing for all of these and calculate these distances. Now, with that in mind, we're going to take these values here and use those to plot our dead reckoning course. So remember, we started at point E, and here's point E on this chart. And what we do is we take from point E, we traveled at a heading of 350 degrees true for a distance of 3 miles. So let's take my parallel rules and find 350 true. Remember, it's true, so I'm using the outer ring with the star. And here's 350 right here. So I'll put my parallel rules in, set it on 350, walk the parallel rules over to my point E, and draw in a course line. Now that represents 350 degrees. The next step is to get the distance, and the distance is 3 nautical miles. I pick up the distance, set my dividers to it, from the latitude scale. Now if you look at this, it's 26 degrees, and here's 5 minutes, here's 10 minutes. So this is 26 degrees in 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. I'm interested in 3.0 minutes. So I'm going to take my dividers, put the point down here at the 26 even, and go up to 3 minutes. And you notice 1, 2, 3. I'm right on 3. I take that setting, put the point on the E, my beginning point, put a little mark there, and that represents 3 miles. Now since this is dead reckoning, I'm going to put a half circle, which is the symbol for dead reckoning, and put the time in. Well, let's put the time first on E. We started at 0700, so let me mark that, 0700, and the date, 9/23/02. This point is 0730. This is where we should be at 0730. Alright, so that's our first DR point. Our next step is to take the second one, 063 true, for 3.2 miles. So I come to my true rows, and here's 90, 80, 70, and it's 63. So 63 is right in there. And I take 63, set that up, and go to my DR point here. Drawing my line. And then I take that distance. Now this is 3.2. So remember, we had 1, 2, 3, and then these little ticks are each a tenth. So I can reset my dividers to 3.2. And this is the advantage of using a divider with a thumb screw, because you can set it and it's not going to change as you shake around and bounce around on the boat. Set this at my 0730 point, put a little mark here, and put a half circle and a dot, and put in the time 0800. Likewise, I do the same thing with the next 309 true for 3.4 miles. And here is 310, here's 309. So I set this in with the parallel rules. Bring it down to my DR point, drawing the course line. Same procedure. Now I have 3.4 miles. So I again set my point here on a whole degree. Turn the thumb screw till I'm at 3.4. Set it, my point at 0800. Put a mark. Put a half circle. And that is 0830. DR point. Likewise, my next one is 063 again, and I'm going to set my parallel rules again, move to that point, drawing my course line. 3.2 now is the distance for that. Readjust my dividers to 3.2. Make that mark. Again, half circle and a dot. And that time is 0900. And my last one is 309 true. And I will do that again, 309. My distance is 3.0. Reset my dividers to 3.0. Half circle and here's my point. Half circle and a dot. This is my position at 0930. Okay, so we have plotted a dead reckoning plot from 0700 to 0930. Now the question is, what is your position at 0930? In order to pick up that position, what we have to do is use our parallel rules, set it parallel to a horizontal line, this longitude scale, and simply walk it up until we get to that point that we just did, and put a little tick over here. Now I want to read the longitude, the latitude of that point. Well, this is 26 degrees, 5, 6, 7, 8, 9.3, roughly 5 or 4. So I read 26 degrees, 09.34 minutes north is my latitude. And then by the same token, I set this parallel to the vertical axis and simply move it until I go through my point, put a little tick here, and now I read my longitude, 75 degrees. Here's 5, here's 10, so this is 75 degrees, 1 minute, 2 minutes, 3, 4, 5, 6, 7 minutes. So this is 75 degrees, 07 minutes, point roughly 42. So that's the process for plotting a DR, dead reckoning plot, based strictly on compass, steering compass, and distance traveled based on the log reading or the odometer. And that's our basic technique for doing that.